methods that a servlet has are do get, do post, and you can probably see a pattern here. You have do methods with various request methods that are part of the HTTP specification. So this servlet is nothing more than a Java object that inherits from servlet and has implementations of the various request handling methods that correspond to the various HTTP request methods. So if somebody sends a GET request for some resource like food, it's going to pick out a servlet. It's going to route that request to the servlet's doGet method, and then that doGet method gets access to all of the different pieces of the request, namely the request line, where it can look at, for example, the resource that was requested. It gets access to the headers. It gets access to the request body, so they can go and do processing associated with that request. So servlets are the underlying and most commonly used technology in Java for handling incoming requests. Now, one of the key questions is, if we have multiple servlets here, how do we decide which servlet should handle a particular HTTP request? Well, inside of most web containers, there's what we call basically a routing function, or some router which decides, based on the request that's coming in, which servlet should handle it. And in Java, the way that servlet handling and routing is specified is through the web.xml file. And this is a specialized file that tells the web container when a particular request comes in. So let's say we get a new request here for /bar.
Like and subscribe.
Bar. It looks in the web.xml file, finds the servlet that it should go to, and then routes the request to the appropriate servlet based on what's specified in that web.xml file. So this is essentially the routing of requests. This is where routing is specified as web.xml. The web container handles the life cycle and uses this routing table to decide which servlet should receive requests, and then the individual servlets process requests. So this is the overview of how the servlet system in Java works to handle requests.
WebSockets build real-time features by establishing a two-way connection between a client and a server. Imagine an online multiplayer game where
Like
the
and
leaderboard
subscribe.
is constantly changing on the server. Now, what's the best way to show the player an updated leaderboard? We could tell them to refresh their browser window every few minutes to send a new HTTP request, or we could use an interval that ticks every few seconds to pull the server for new data. But these options aren't ideal for real-time data, and that's where WebSockets come in. The first step is for the client to send an HTTP request to the server asking to open a connection. If the server agrees, it will send a 101 switching protocols response, at which point the handshake is complete. The TCP IP connection is left open, allowing bidirectional messages to pass between the two parties with very low latency. The connection will stay open until one of the parties drops off, then the TCP resources can be unallocated. It's often referred to as a full duplex connection, which is a telecommunications term that defines how a phone line works where both parties can send messages or talk at the same time. Let's see this in action by creating a real-time connection between a Node.js server and a web browser. We'll start in our backend code by building a WebSocket server with Node.js. Using the WS library, we can instantiate a new server on port 8080. Everything is event-based, and the first event we can expect to happen is a connection from the client. When the connection is made, we'll have access to a WebSocket object in the callback. With the initial handshake done, there are two things we might want to do here. We can listen to incoming messages, which would just be text in this case, and then handle them accordingly in the callback. The second thing we might do is send a message back to the client, which we can do with the send method. Now let's take a look at our client-side code in the browser, which has a built-in WebSocket class. It's instantiated with a URL that points to the server, but notice the WS protocol. That will automatically trigger the handshake to open the connection, which we can listen to as an event. Just like on the server, we can use the socket to both listen to and send messages. And we now have a full duplex connection between a front-end JavaScript app and a Node backend. This has been WebSockets in 100 seconds, but if you want to learn more, make sure to stay tuned, because today we're going beyond 100 seconds to learn all about a library called Socket.io and look at a couple of APIs that might replace WebSockets in the future. But first, make sure to like and subscribe. And if you're into real-time apps, check out my Firebase content on Fireship.io. Now, one of the issues that is not so obvious with our current implementation is that the server cannot broadcast a message out to multiple clients simultaneously. Like, for example, a group chat room where you have multiple users passing messages back and forth. It's definitely possible to build something like that from scratch with WebSockets, but there are libraries, like Socket.io in this case, that can make features like that much easier to implement. You can think of a WebSocket as a low-level building block, where Socket.io is a more practical library that solves common use cases and provides failovers to different protocols when needed. If you're building something real-time, there are many different options out there. You might look into Firebase, Apollo GraphQL, or an API like Pusher. Once you bring a database into the equation, real-time features can become very complex, and using a paid service can be well worth the money in my opinion. In any case, let's go ahead and get started with our Socket.io project. At this point, you can open up VS Code to follow along and access the source code on GitHub. What we're going to build here is a bare minimum implementation of a group chat room. When a user opens up the app, they can post a message, and anybody else on that same URL can view the message. And again, one of the big differences from the previous implementation is that the message will be broadcast to all of the connected clients. As you can see in our code, we have a directory for server and app. Server is the backend, app is the front end. In the server directory, we'll initialize an npm project by running npm init y. Then we only require one dependency, which is Socket.io, and we can install it with npm. Now, in the index.js file, we need to create an HTTP server. We can do that using the built-in HTTP library in Node by importing it, then calling the create server method. However, it is worth noting that you might want to use Express here instead, which is a much more popular option for building an HTTP server. The next step is to import Socket.io, which is a function, and it will take our HTTP server object as an argument. But in this demo, we'll be accessing the backend from a front-end browser application. But for security reasons, cross-origin resource sharing, or CORS, is disabled. We can pass an object as a second argument, and we'll set the CORS origin to anything, allowing any URL to access our backend URL. And now we can implement the logic for Socket.io. Just like WebSockets, it's an event-based system. And the first event you'll likely want to listen for is the connection of a client from the front end. The callback will give us access to the socket object. And on that socket, we can listen to any custom event we want. But for simplicity, we'll just call it the message event. When an event is emitted, we'll have access to the data, which might be a JavaScript object or a string, and we can handle it inside the callback here. In this case, it'll be a string, which we can console log, And because we have multiple clients listening to the message event, we can then re-emit the message so it's broadcast out to everybody. We can do that with the IO emit method, and then we'll pass message as the event name, and then whatever custom text or data we want to pass as the second argument. And that's basically all there is to it. It's a very simple event-based system. The final piece of code we need here, though, is to tell our server to listen on port 8080. Then you can open up the terminal and call node and point it to this file to run the script and start your socket.io server. And now we're ready to move on to the front-end code in our app directory here. If we open up the index.html file, you'll notice I have a script tag here pointing to the socket.io CDN for version 3.0. It's very important to understand that socket.io is not a direct WebSocket implementation, which means you can't just use the built-in WebSocket class in the browser. Instead, you have to use the socket.io client library, which we're doing here through the CDN, but you can also install it with NPM and bundle it into your project if you're using something like React or Angular. After that, we have a script pointing to the app.js file, which is our custom source code, and I'm using the defer attribute to make sure it loads after the body content. Then in the body itself, I have an unordered list, which is where our chat messages will appear, and then below that I have an input for the user to type a message and a button to send it. And now we can move over to our JavaScript file. The IO object will now be globally available in the browser, which is the socket.io client library. We can create the connection by pointing to the URL of our server, which is localhost 8080. And now we're ready to start listening to events. By calling socket on, we can listen to the message event emitted by the server. And we can use some imperative browser APIs here to create a new list item element and then append that item to the unordered list in our HTML. And that's all it takes to create a feed of messages in the UI. The only thing left to do is give the user the ability to send a message. We can handle that by listening to the click event on a button. When clicked, we'll grab the text or the value from the input element, and then we'll call socket emit with the message event and the text. Congratulations, you just built a real-time chat app with socket.io. Obviously, there's a lot more to building real-time features in the real world. Events get emitted, and then you listen to events and handle them accordingly with functions. Now, before we finish up, there's one last thing I want to talk about, and that's the relationship between WebSockets and other APIs like WebRTC and a new experimental API called WebTransport. First, let's talk about WebRTC, which stands for Real-Time Communication. It's also a tool for building real-time experiences, however, it's geared towards browser-to-browser communication, primarily for video and voice. If you're building a video chat app like Zoom, you probably want WebRTC and not WebSockets. And another new API that people have started talking about is WebTransport. And without getting into the details, it's basically a better version of WebSockets, faster handshake, better reliability, and stuff like that. Its proposal is still being stabilized, so nothing you need to know today, but just something to have on the radar for the future. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe. Consider sponsoring me on GitHub or becoming a pro member at Fireship.io. Thanks for watching, and I will see you in the next one.
Paradigm. Paradigm. Paradigm.
Before continuing this video,
Yo, we have finally made it to object-oriented programming in Java. So, what is an object exactly? Look around wherever you're sitting right now. You are surrounded by different objects. For example, next to me I have my phone, a cup of coffee, and a microphone. In programming, an object can represent a real-world entity. They can do one of a few things. Objects
Like and subscribe.
hold data, and they can perform actions. The data they hold are known as attributes. The actions that they can perform are known as methods. Objects can have things, and they can do things. Some attributes that a person may have would be a name, their age, their height, and their weight. A few methods, meaning actions that a human could do, a person, well, they could eat and they could sleep. Objects are reference data types. We store the data for an object in a location known as the heap. In this demonstration, we're going to be creating some car objects, but we'll need a class. A class can serve as a blueprint to create objects. So what we're going to do is create a new Java class. We will create a class of car. We have two classes, our main class and our car class. A class can behave as a blueprint for creating objects. We'll start by listing the different attributes that a car may have. So what does a car have exactly? Well, a car could have a make that would be a string. We can assign it if we would like. Think of a car you like or a car you drive. I'll pick my favorite car. The make will be Ford. Another attribute could be a model, and I will pick a Mustang. Cars could have a year, that would be an integer. Int year, I'll pick the year 2025. A price, that could be a double. Double price equals, let's say, $58,000.99. A car's engine could be running, that could be a Boolean. Boolean is running. I will set that to be true, or false, if the car is turned off. Things that an object has, in this case car, these are known as attributes. They are things that an object has. Now, heading back to our main class, we will create a car object. We're already a little familiar with working with objects. For example, a scanner is an object. To create a scanner, we would type scanner scanner equals new scanner. Then you type system.in. Or with random objects, we would type random random equals new random. Now to create a car object, we're going to be utilizing this class. We'll type car, then think of a name for this car. We'll just say car, all lowercase, equals new car. We're following a similar pattern. Car equals new car. We don't need the scanner or this random object. I was just demonstrating something. We now have a car object that we can use. Our car object has these attributes, these things. If I was to print my car object, here's what we can see. Well, since objects are a reference data type, if you were to print your car directly, you get a memory address. If you need to access one of these attributes, you have to follow the object name with a dot. A dot is known as the dot operator. It allows you to access things within an object. If I need the model of my car, I would take my object name, use the dot operator, followed by the attribute name. If I was to print the model of my car, that would output Mustang. Let's print some of the other attributes. Car.make, who manufactures the car? Ford. What is the year of my car? Car.year. 2025. What's the price? Car.price. $58,000.99. Is my car running or not? Car.is running. False. The car is not currently running. You can modify and change these attributes too. With our car object, let's access the is running attribute. I will set that to be true, like we're turning the car on. Is running is now true, because we changed the attribute of is running. Not only do objects have the capability to hold data, meaning attributes, they can perform actions. They can have their own methods. Going back to our car class, we'll define a few methods. What sorts of actions can a car take? Well, we could start a car. Within this class, we will define a method. We don't need that static keyword this time. We need a return type. We'll say void, we're not returning anything. We will define a method of start. Let's do the following. Let's output you start the engine. We'll create another method. Void stop. Let's say you stop the engine. So now with our car, we can delete these print line statements. We'll take our car object, use the dot operator, call the start method. This should output you start the engine. Or we could stop. Car.stop. You start the engine, you stop the engine. Not only that, within these methods, let's change one of these variables, one of these attributes. Within our start method, let's take is running, set that to be true. Within the stop method, we'll take is running, set that to be false. Going back to our main class, before starting the car, let's output car.isRunning. After starting the car, let's output car.isRunning, and then stopping the car, we'll output car.isRunning. The car is currently not running, that's false. You start the engine, the car is now running, that's set to true. You stop the engine, the car is no longer running, that is false. Let's add two more methods. We can start, we can stop, we can drive. We'll create a method to drive, void drive. Let's output you drive the, I'm going to use string concatenation. We'll concatenate the model of the car. So my car is a Mustang. We will create a method to brake. You brake the plus our model variable, our model attribute. We can delete these lines of code. Let's drive the car, car.drive. You drive the Mustang. And here's the model of the car. And we can brake, car.brake. You drive the Mustang, you brake the Mustang. There's one issue with this, though. With our class of car, every car that we make has the same attributes and methods. We can only create 2025 Ford Mustangs. If I was to create another car object, let's say car2 equals new car, we'll rename the first car as car1. And I'll output some of their attributes. car1.make plus a space plus car1.model. We'll do this with our second car object too, car2. car2.make, car2.model. These cars have the same attributes. It would be nice if we had a way to customize them so that each car is unique, because currently they're all the same. They're different cars, but they have the same attributes and methods, which is kind of lame. That's why in the next video, we're going to discuss constructors. By passing in arguments, we can create unique objects. In summary, an object is an entity that holds data. It has attributes. And they can perform actions. They can perform methods. They have things, and they can do things. And well, everybody, those are objects in Java.
inevitable, inevitable, inevitable,
Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about encapsulation in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Let's talk about encapsulation. This is the concept of attributes of a class being hidden or private. They can be accessed only through special methods called getters and setters. And you really should make attributes private if you don't have a reason to
Like
make
and
them
subscribe.
public or protected. in this tutorial series, I don't, just for learning purposes. I want to make things as less complicated as possible, so I tend to not use encapsulation, but for your own programs, you probably should, just to add a layer of security. So I have an additional class for this example called car. Let's make some private variables. So let's say we would like a make, a model, and a year. So I want to make these private so that only this class can access them. So private, string, make, private, string, model, and private, int, year. Let's also set up the constructor of the class while we're here. So the parameters are make, model, and year. String make, string model, and int year. And when we construct a car, we'll just say this dot make equals make, this dot model equals model, and this dot year equals year. Now let's attempt to construct a car object. So car equals new car. What kinds of arguments do we want to pass in? We need a make, a model, and a year. So for this car, let's say that this is a Chevrolet. The next argument, maybe a Camaro, and a year. 2021 is good. So this will work just fine. What would happen if we attempt to access one of these private members, like the make, the model, and a year? Let's find out. So system.out.println, I'm going to attempt to print the car's make. And let's see what happens. Well, there's a problem. The field car.make is not visible. That's because this is private. All of these variables are private, so they are hidden. Only this class has access to these members, make, model, and year. So what can we do to retrieve the value of one of these variables? We can use a getter method. So that is a special method found within the class that contains these private members that will send the make, the model, or the year, whatever variable you're working with, to whatever class is calling that method. So we're going to create a getter method for each of our variables that are private, make, model, and year. So let's begin with make. So this is going to be a separate method. It's going to be public. The return type is a string, and we will call this get, then the name of the variable, make. And all we're doing is returning the make, and that's it. Let's repeat the process for model and year. So public string get model, return whatever our model is. And lastly, this is returning an integer, and this is get year, return year. And in order to access one of these attributes, one of these variables, we need to use the appropriate getter method. So instead of accessing this attribute directly, we're going to use one of these methods. Get, and we have make, model, and year. So let's get the make of this car, and it's going to return Chevrolet. So it's as if we're asking this class nicely, can we pretty please get the make, the model, or the year of your car? So that's one way in which you can access a private attribute. You use a getter method, and then you can call that method from anywhere, basically, since we made this public. And if you need to retrieve the other private variables of this class, you just use the appropriate get method. So let's say we want the model, so car.getModel, and the year, car.get year. So this will retrieve all of the private variables of our car object. Chevrolet Camaro, the year is 2021. So now how can we change the private attributes of an object? Well, we can use what's called a setter method this time. Let's attempt to change the year of this car. Car.year, and we'll change this from 2021 to 2022. Well, the issue that occurs is that the field car.year is not visible since we set this to private. So we would need to create a method called a setter to set the year of this car, the make, the model, and the year. It's kind of like what we did with our getter methods, but these are called setters. So let's create a setter method for the make, the model, and the year so that we can call this method to change one of these values. So this is public. The return type is void. We're not returning anything. And we'll call this set, and then the name of each variable that you're working with. So let's create a setter for the make. And we do need one parameter, whatever our make is. So if we call the set make method, we have to pass in a new argument. So string make. This dot make equals make. And actually, since we're setting the make here within a setter method, we no longer need this line. What we could do is call the set make method within the constructor now. So this dot set make, and we have to pass in our make. And let's repeat the steps for model and year. Set model. This will take a string model. This dot model equals model. And we no longer need to set that within the constructor. We'll just call this dot set model and pass in our model. And lastly, we have the year. Public void set year. This has one integer parameter, int year. This dot year equals year. And we can just call that method. This dot set year and pass in our year. And now if we need to change one of these values, we can use the setter method, car dot set year, and we'll pass in a year, like 2022. And then let's display all of these values using our getter methods. And now our car is a 2022 Chevrolet Camaro. Well, that's the basics of encapsulation. All we're really doing is making the attributes of our class private so that they cannot be directly accessed from elsewhere within our program. If you need to retrieve one of these values, you can use a getter method. If you need to change or set one of these values, you can use a setter method so that you can indirectly either get or set these values, and other classes do not have direct access to these values. So if you'd like a copy of all this code, I will post everything in the comments down below. But yeah, that's the basics of encapsulation in Java. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow pro.